we all take a seat? Yeah, so the second talk will be given by Michael Snoyman. And who knows Michael? Or maybe I should ask who doesn't know Michael? Yeah, because he's a very popular and very influential person in the Haskell community. He's the author of like a lot of popular open source projects and tooling around Haskell. In fact, his company, Epic Complete, are the ones sponsoring the Stack tool. He's also the creator of Yesod. That's one of the few popular web frameworks in Haskell. He also authored Concrete. Also, that's another popular library. So he's a prolific developer in the Haskell community. And today he's going to be talking to us about deploying Haskell services. And the reason why I actually kind of asked him to do this was because there's this thing about Haskell in the sense that people have this myth that Haskell is not a practical language, that you can actually do practical stuff, like build applications that you can actually deploy, monitor, think about all of the security, the whole back. So I was like, okay, this is someone that could actually talk about the practical stuff of actually putting Haskell into production. I reached out to him and he was kind enough to give this stuff. He's talking, he's calling us from Israel, and we'll be spending the next 30 to 45 minutes with us. So Michael, it's over to you now.
Awesome, thank you very much for the introduction. Hi everyone, this is fun doing a remote meetup. Just so everyone knows, I can't exactly see the audience, it's kind of dark over there. I have no problem if people want to ask questions in the middle, but you may have to speak up a little bit to make sure that I'm able to hear if any questions come through. Also, just sound check, is everyone able to hear me clearly?
Yes.
Awesome. Okay, very good. So I'm going to turn off my video to make sure you guys are able to see the slides well, and I'm going to dive in. So we're going to be talking about deploying Haskell services today. So Haskell network services. At FP Complete, because that's where we're going to be talking about a lot of this stuff. FP Complete's the company I work for. We use a lot of Haskell in our deployments and mostly in our deployed network services. So that would be web applications, other kinds of applications along those lines. We build, we deploy, we monitor these things. All of these are kind of operations topics. And the question is, why in the world would we use Haskell for this kind of stuff? So, one kind of giveaway is the fact that we're called FP Complete, functional programming. So we actually kind of care about Haskell. But beyond that, we do see a lot of benefits, and I'd like to mention those first. So there are some general benefits of Haskell that we're able to take advantage of. We get reliable code. We consider it at least highly productive. We're able to get a lot done in a short amount of time. It's a productive language. We have a lot of success scaling to large teams. Now this applies internally to FP Complete. We're able to throw more people at projects, but also when we work with a lot of our customers who are deploying Haskell services, we find that they're able to pretty easily scale the teams up. And we attribute a lot of this to the typing system in Haskell, the fact that so much of the way that you interact with an API or with a code base is based around types really helps people figure out how to get oriented quickly. And yet again, tying into the types, the fact that we have a strongly typed language means that we're able to avoid large classes of bugs right off the bat. Yesod, for example, that's the web framework that I'm the primary author of. It's able to avoid a whole bunch of cross-site scripting attacks right out of the box based off of the type system. It's able to differentiate between trusted and untrusted content. That's just one of the kind of cool things that you're able to get away with when you have a strong and flexible type system. But we're talking about network services for the most part. And the question is, what makes Haskell cool in those cases? And these are the kinds of things that you don't usually hear right off the bat. A lot of the time when you talk to Haskellers, you're going to hear about, ooh, it's functional and it's got immutability and you're able to think about categories and things like that. We don't care about any of that stuff today. Right now, when it comes to network services, Haskell is actually a very strong language outside of all of those really awesome functional features. One of the things it's got green threads, meaning that it is easy to spin up thousands, tens of thousands, hundreds of thousands of individual threads. It doesn't tax your system. You're able to write code in the simple blocking synchronous manner that we like to write code in, but you get a nice asynchronous runtime under the surface. And there's been some great work, great improvements to the green thread, the runtime system in Haskell over the past 10 years or so. It's kind of a work of art. I know that they were able to discover some bugs in the Linux compiler with some of the work that they were doing. So cool stuff there. So the runtime is an efficient runtime. And then there are some servers like Warp, which is I'd say the de facto standard web server in Haskell these days. And they're highly tuned, and you're able to just grab this and start working without having to worry too much about efficiency. These things are taking care for you behind the scenes. Immutability, purity, and STM. So STM, for those who haven't heard of it, software transactional memory. When it comes to network services, the issue of how you share state amongst multiple threads comes up a lot. And I'm not going to be getting into STM today. I actually have a few talks. You can go to my blog, my website, Snoyman.com, and see some of the talks on things like STM. You can do some amazing feats of immutability in Haskell because of its basis in immutability and purity. And when we're talking about these kinds of highly concurrent web services or network services, this really comes into play a lot. Haskell overall has a low memory footprint. It's not as small as like hand-rolled C++ or Rust or something along those lines. It is still a garbage collected language, but overall, it's a lot better than a lot of other languages, and it's probably in the same ballpark as Java, C#, Go, I think, as well these days. Relatively speaking, it's got a low CPU overhead. Haskell's very, very optimized. There are lots of optimizations built into the language, and for the compiled executable, this makes it a lot easier to deploy your services. You don't need a huge machine, and we're going to see how that ties in with some of our deployment strategies a little bit later. And finally, compiled executable. Who in the crowd has ever worked as an ops person, a DevOps, sysadmin, anything along those lines? Okay, a little bit, not as much as I expected. Deploying a compiled executable can be significantly simpler than say a scripting language or something else where you're going to have to deal with the runtime, making sure the same version of the runtime is deployed. For the most part, compiled executables make this much easier. So how do you deploy a Haskell service? Let's talk about a simplified version of this. Since we're talking about compiled executables, go ahead and spin up your local laptop, write some code, compile an executable, go to DigitalOcean or wherever else you have your VPS, spin it up, copy your executable directly to the VPS, SSH in, run screen, run the executable, and you're done. You've got a network service up and running in probably 10 to 15 minutes flat. And that's a reasonable way of getting started, but there are a lot of limitations to this kind of a deployment. Some of the problems. Let's say that you're using Ubuntu 18.04 on your local machine and you deploy to Red Hat, or you even deploy to Ubuntu 16.04. You're going to get a whole bunch of errors because of shared libraries. Not sure if anyone here has ever run into those kinds of things before, but they are a pain to deal with. They're usually associated assets. When you're dealing with a web application, typically speaking, there are going to be some CSS files, there may be some config files, there are going to be a bunch of other things floating around that you need to make sure you're deploying together with your application. So copying over an executable is going to help, but it may not give the entire story. It may also be a little bit difficult to make sure you found all the files that need to get deployed. It makes it difficult to test. Let's say that I've gone ahead and I've written a thorough test suite locally. I'm going to keep running with the web application example. For the moment, let's say you got some Selenium tests up and running, You've made sure that your application runs perfectly, you deploy it, and boom, everything breaks. And you don't know what the difference is. Is it because of the different IP addresses? Maybe the database server is tied to only accepting certain IP ranges. Or maybe it's because you're missing a file, or who the hell knows what is going on. So those are the kinds of things you have to be careful about. Downtime during deployment. Let's say that you've got a new version of your application and you copy it across, you close out the old version of the application, it's closed for 5 seconds, 10 seconds, you start up the new executable, you've got 10 seconds of downtime. Maybe that's not a big deal. But what if there was some kind of a bug and you're not able to get the new version started up right away? 20 minutes, 30 minutes. It's not unreasonable for some kind of a bug like that to exist, and your users are sitting around looking at a blank screen. That's not good. What happens if the machine fails? What happens if there's a hardware failure, the CPU overheats, an asteroid hits the data center? Who the hell knows? All of those things are problems that are not addressed with this kind of a simple deployment strategy. So there are a lot of approaches out there. Also, I'm just gonna ask for a show of hands again. Who here works in general in some kind of a network or web kind of services deployment, as in they work on the software for it? Okay, cool. So you guys are probably familiar with all the things that I just mentioned, and you're probably familiar with a lot of the solutions. I could tell you that there's, you may be expecting me to come up with some kind of Haskell specific functional programming approach. The answer is no, at least not here at FP Complete. The way that we typically do our software deployments, we like to go with standard tools. There's a term called novelty budget that we bat around, not just here, and others in the Haskell community use it as well. We try to conserve the novelty budget. If there's a feature, if there's a tool that brings a lot of value to the table, use it. But don't try to avoid using too many unusual things. You're now going to be fighting an uphill battle. So we like to, on the deployment side at least, stick as much as possible to standard tooling. So this would be things like Docker, Kubernetes, AWS, and all of this ties in very nicely with our Haskell applications. I'll show you what a standard deployment kind of looks like. Typically speaking, we like to use GitLab for our CI. We have our own internal GitLab instance. We store our code in our internal GitLab instance, customer code in a GitLab instance. We then use the GitLab runners to go ahead and build the code. One of the things that we really like about GitLab is the fact that the configuration for how to do the builds is stored inside the repository in a file. This has become pretty much standard practice in the past 5 to 10 years, but it's very different than the way things used to be back in the old days. I was going to be a graybeard and talk about how Jenkins used to be 15 years ago. I think things have changed for the better quite a bit. So anyway, we like GitLab. It's got a Docker repository kind of built in. From our CI, we like to build a Docker image right off the bat. And it's true that Haskell does have that advantage that I mentioned about being a compiled executable, but it's much simpler at the end of the day to be able to package up all of the dependencies, those static assets I mentioned, all the shared libraries, get everything into a single Docker image. There are alternative approaches out there as well, but that's the one we tend to stick with. We have a stack.yaml file. We use the stack build system for the most part, or actually for all of our Haskell builds. And this is one of the things that we really like, is the fact that it gives us an identical build plan. It ties down the version of the compiler we're using, the version of the libraries that we're using. And as a concrete example that happened to pop up for me, I needed to make a trivial change to one of our Haskell web applications last week. No one had touched it for a few years. It was on a version of GHC that I think is 4 years old. Typically, with most things out there, I'd be a little bit worried about making a change to something that hasn't been touched in a few years. I made the tweak to the HTML I needed. I hit push, and thanks to this, this guaranteed identical build plan, everything built and deployed without an issue. So that's a really nice thing that we like. And the output of all of this is a Docker image that we're able to use for the runtime deployment. That's our basic CI story. Again, I mentioned that the video is a little choppy. Were there questions that people wanted to ask? I wasn't sure if I saw people raising their hands.
No questions?
Nope.
Okay, yeah.
How do you build the Docker images?
Sorry, could you say that again?
How do you build Docker images?
Oh, how do we build Docker images? So in previous versions of Stack, this was back when Docker was a little bit more primitive, we built support for generating Docker images directly into Stack. One of the great improvements that came out in Docker in the past few years was multi-stage Docker files. And that's the thing that we use these days. So for those who aren't familiar, a multi-stage Docker file will allow you to have in the same Docker file, it will specify a build image, in our case, for example, a build image and a runtime image. So in the build image, we'll go ahead and we'll install the full build toolchain. We'll install the compiler, we'll install all of the development versions of the libraries, everything else you could possibly need, pull in the source code, and run stack build. And the output from that is going to be some executables. But now you've got a massive image that's got all this stuff that you don't want shipping into production. It's a security hole to have extra stuff in an image that you don't need, especially something as dangerous as a compiler. With the multi-stage builds, what you're able to do next is start off a new image, the thing that's going to actually become runtime, copy the generated artifact, so the executable, the static resources, the config files, everything else, copy that into the runtime image, and that's basically the way we do things these days. It ties in really nicely with GitLab. Since GitLab has the built-in repository, we're able to use GitLab's authentication system and go ahead and push those images directly into the directly into the Docker repository. Registry. I keep saying repository. It's the Docker registry. Sorry about that. Does that answer your question?
Yes, thank you.
Cool. Okay. So testing. Who here has ever heard the horrible, horrible line, if it compiles, it works? It is a lie. It is a horrible, horrible lie. It is not true. There are definitely some classes of bugs that don't occur when you have a good, well-typed system. However, you can still cheat a lot of the time, and you can not use types, not protect yourself. And even if that's the case, even if you had the most beautiful Haskell code on the planet, and it looks like not a single bug could ever possibly exist there, you're still interacting with the outside world. You're going to be talking to a database. You're probably going to be, calling out to some kind of C code. Even if you think you're not calling out to some C code to do some work, guess what? You're going to be making system calls that are talking to a kernel that's written in C. You've got plenty of surface area for things to go wrong, even if you don't think so. And so, yes, you have to test. Using Haskell is not an excuse to avoid testing. Please make sure, you may notice I'm a little scarred on this one. Make sure you let everyone know you have to test your Haskell code. Anyway, unit tests are nice. The thing I care a lot more about, especially for these kinds of systems, is integration and system tests. Making sure that your full application is actually interacting well with the rest of the ecosystem that it's going to be deployed to. Probably going to have a few different databases. You may have a microservices architecture. I actually am not a huge fan of microservices architectures, but they are very common these days. And talking to a bunch of other things over HTTP, that's a recipe for things breaking. One of the reasons why we really like this Docker-based build and deployment is you're able to test the exact same Docker image that you're about to deploy to production. One of the first times that we did a major Docker-based system like this was for a regulated device where we had to report some answers to a US government agency. And one of the, we were able to make quite a few claims about the build based off of the fact, the way that we were doing reproducible build plans and the way we were using Docker for the builds, but also this fact that we were going ahead and testing exactly identical images to what we were about to deploy really helped out a lot. Staging. So once you have this image, once you've tested the image, time comes to go ahead and put it somewhere where you can start reviewing it a little bit more closely. this doesn't always happen. We have some kind of continuous deployment setups also. Things go directly to master and you rely on the test suite. But I think it's more standard these days for a lot of people to go ahead and have a staging server and have a manual approval step before doing deployments. And that's definitely something we do very commonly. What we have is we have separate CI and production Kubernetes clusters. I haven't spoken yet about how we do the production deployments, but spoiler warning, we are actually using Kubernetes a lot of the time. GitLab has a great feature. They've got this thing called review apps. So instead of having a dedicated staging branch, and that's the only thing that gets pushed out, get tested, and then you have like two people who want to test their branches at the same time, and they're fighting over staging, and it's a mess. Instead, you can just have as many different review apps deployed at the same time for your application, and then get them garbage collected afterwards when you're done using them. And this is actually a great way to interact with product owners, whether they're inside the company or customers who are the product owners or other developers, whatever the case is. Let them see what's going on. It's a lot more convenient than trying to teach someone, okay, so now you're going to install Vagrant, and now I want you to spin up Vagrant on your Windows machine. Now I want you to download this thing, and then I want you to log into Docker registry and run this, and then you're going to have to set up some port forwarding, and then you're going to be able to test. That's a mess. Being able to have a nice staging deployment is really great. Production, we use Kubernetes. We use the deployment system. So Kubernetes has gone through many different iterations of pods and pod sets and deployments. We're on deployments right now. I guess the next thing is to move up to Helm charts, which we've actually started doing as well. Kubernetes, who here's used Kubernetes? Does anyone think it's a well-designed tool? Wow. No one? Okay. I actually hate Kubernetes. I think it's poorly designed. I think it's a mess. But this is where that whole concept of novelty budget comes in. The world, for better or worse, has standardized on Kubernetes at the moment. You can go to any of the cloud providers, and they're providing you with some kind of a Kubernetes system. At this point, it's not worth fighting the uphill battle. We could say, we're going to rewrite this whole thing. I'm going to make my own Kubernetes with Blackjack and Haskell or something like that. But no, it's not worth it. We're going to reuse this thing that's already out there. Every once in a while, we flirt with Nomad, if anyone's familiar with Nomad. We like the HashiCorp set of tools. But still, we're using Kubernetes for most of these things. And specifically with the deployment system, a lot of those issues that I mentioned before about, like it does blue-green deployments correctly. The ability to say we're going to have we're going to have 3 replicas of the pod running in production, and before you tear down the 3 prior ones, spin up the new ones, test them, make sure that they work. This is all great, and we're able to avoid downtime for deployment. One of the perennial issues in any kind of network service like this is mutable resources, like a database. If you have a new version of the application and it has a schema change, or it has some new data that the old system doesn't work, you didn't even need a database for this. You could just be writing to files on a shared file system. But if the file format and the old system doesn't understand it, it's a problem. I'm not going to get into the there are lots of ways of dealing with this, stage deployments, the ability to roll back schema migrations, all those things exist. This is yet another one of those cases, though, where you just got to do the same thing in Haskell as you would in any other language. You're not getting any kind of specific benefit. And the moral of the story is that mutability always sucks. So you should just use systems that never change ever at any point. That's a joke, and I guys can't see my face. Okay, high availability. Again, we're still going along with standard ways of doing things. So we do, all of our deployments, all of our production deployments at least, multi-node, multiple availability zones. So this makes sure that if a host goes down, or if an entire part of a cloud data center goes down, an availability zone goes down, we are protected. We use a load balancer to make sure that the load is distributed so that we're able to do scaling, and so that we're able to recover from some bad nodes, and an auto-scaling group is the second component in making that kind of a load balancer work. These days, most of what I just described is not actually part of our application deployments. Most of it is part of Kubernetes itself. Kubernetes is the orchestration system we're using. It has to be highly available itself, and then our applications are simply able to rely upon Kubernetes. Though at the end of the day, there are still some cases where we're ditching Kubernetes for whatever reason, and we're still deploying things directly onto, bare metal, meaning onto a virtual machine running on top of a Zen hypervisor on a cloud that we have no control over. That's considered bare metal these days. So we're still doing bare metal stuff every once in a while. Configuration. You guys ever hear of 12-factor, I think they call it the 12-factor app? Maybe? Doesn't matter. The way that we do most of our configuration in Haskell code these days is with YAML config files. So there's a package, I'm actually the author of it, the YAML package, and it's got this module called data.yaml.config. And the one thing that it's got, it rips the syntax off directly from the Ruby world. Again, don't try to reinvent things, just steal what other people are doing already. You can go ahead and do environment variable overrides. And for those, since it looks like a lot of you are familiar with Kubernetes, you already know you can set Kubernetes, you can send environment variables during deployment. So this way, we're able to have nice config files and be able to specify at deployment time what kind of specific settings we want. Secret credentials tie into this as well. Let's say you've got a database password. Those kinds of things, for the moment, we're using Kubernetes secrets. And so we'll end up putting together a file that has all that information. And then as part of the launch script for that pod, we'll mount the secrets, we will read them into an environment variable, or pass them in as a command line argument. We're actually in the process right now of moving a lot of this over to Vault. Has anyone here ever heard of Vault? HashiCorp Vault? Okay, so not so much. Vault is a really cool system. It's difficult to say in one sentence what it is because it does a lot of stuff, but for our purposes, it's a secrets management platform. So instead of having this stuff in Kubernetes secrets, we're moving a lot of our stuff over to Vault secrets, which doesn't seem like it's much of an improvement. It's one secret engine versus another, except with Vault, we're able to do things like use its transit backend to offload the encryption from our applications to Vault itself. Again, that doesn't sound like a huge improvement, but that means that we're not holding private keys on the public-facing pods, which is a nice layer of protection against some kinds of hacks. And then with everything that I'm describing to you with this way of doing configuration, we're really able to do different configurations for staging and production very easily. This is not oh, look how awesome Haskell is. Every other language does it. This is just the way we do it in Haskell. Logging. This is one that actually pops up in discussions a lot. Our way of doing logging in the Haskell world, or in the Haskell code that we're writing, we just dump output to standard out and standard error, and we make it 100% an operations topic how to capture the logs. So whether that's throwing it into Logstash, whether it's letting Kubernetes handle the log management, whatever the case is, we leave that up to the operator to handle. We do not do, for example, log rotation and file writing in the Haskell applications themselves. I know that there are libraries for doing this kind of thing. Is my audio still coming through just fine?
Yes.
Okay, great. The library that we use for that these days is Rio, which is something we've been working on for about 2 years, maybe a little longer now. Here at FP Complete, I'm not quite sure how long. And it does some nice efficient things around log management, but that's a talk for another time. Why, how to do efficient I/O in a language like Haskell, which is a cool topic, but not the one we're talking about today. Some people like to use structured logging. We've used structured logging in the past. Sometimes there's a regulatory requirement for additional information. That, again, when we do that kind of structured logging, we'll, for example, dump JSON directly out, but we'll still continue using standard down and standard error. controlling the log level with environment variables. So we can turn on, if we need a little bit more debugging information, we can go ahead and redeploy with the change to the environment variables to convince our applications to be a little bit louder. And at the end of the day, we're using standard log aggregation tools. Though we do have one log aggregation product internally, which we may be announcing in the next few months. But for the most part, we still stick to mostly standard stuff around this. Monitoring, we rely on Prometheus, Prometheus, Grafana, that whole stack. We don't actually, for the moment, tie monitoring in too closely with most of our application code. Prometheus does allow doing things along those lines. We just haven't gotten around to it. For the most part, we found that the standard node level and cluster level stats are pretty useful, knowing about the memory usage, CPU usage, being able to monitor network ingress and egress. And probably the nicest thing to know is if you're dealing with a web application or any kind of HTTP application, is there a higher than normal rate of error status codes coming out, and getting alerts for those kinds of things. Monitoring and alerting tie in very nicely to each other. I think right now in all of our cases, we're using alerting being sent to a Slack channel, though in the past PagerDuty and other things like that have existed as well. So for a Haskell meetup, I did very little talking about Haskell. So, enjoy. The message, though, to come across is Haskell works for these kinds of standard systems that you want to deploy. You don't have to rewrite your entire operation stack in order to use Haskell. It ties in very nicely. You get a lot of great benefits of low CPU usage, low memory usage. You're able to get these nice compiled executables. You get reproducibility around it. You get, at least in my experience, in my opinion, you get a lower bug rate overall from the application itself. So you can go and spend more of your time fighting with operations issues, which is, of course, where 90% of things go wrong most of the time. And if you do high-quality DevOps work around all this, we've definitely found that the Haskell and DevOps combination leads to very reliable services. So yeah, those are my slides. So thanks, everyone. I'm not sure how much time we have left, but I'm definitely around for questions. Okay, and I guess I will switch to video. Hi, everyone.
Yeah, you can ask the question. Yeah.
Hi. Hi there.
Oh, hey.
Yeah, it's not, but I don't know how much of a question it is, or more like a consideration. You mentioned about storing your secrets in a configuration files, text files, and okay, this is a standard thing with Kubernetes and other container orchestration systems, which is basically dumbing down all the configuration to standard environment variables and strings, which then the application is responsible for instantiating their own database connection, etc. Which is kind of a step back from, say, like the Microsoft component object model stuff from the good old days, or JE or remote objects.
Mm-hmm.
I was wondering, of course, on an operating system abstraction that does not allow you to convey the types of the objects that you're passing to an application, that being Unix, everything is just a file, if you're lucky. You cannot really pass an application, this is a database connection, or this is another kind of object with a certain type, API, etc. But maybe with a system that with a stronger type, like a Haskell, for example, wouldn't it be interesting to see maybe a typed environment where the application is handed basically the injection of the configuration, not just the configuration parameters, but actual the configuration objects. Inversion of control is achieved at a container level, at the cluster level. It was just like a thought I had.
No,
If you can elaborate, or if you can think, yeah, we've thought about it. It's just crazy. Forget it.
no. I think it makes a lot of sense. This is one example of something that I've called for a long time the boundary issue. You can have this beautiful piece of Haskell code that is well typed and well architected, and at the end of the day, you've got to deal with some kind of a boundary. So the original use case that I had for this was you want to talk about typed safe URLs. This is something we've got in USOD. So you have a special data type to represent all of the different routes that you could be pointing someone to in your application. And that's beautiful, and it means that you can't accidentally generate an invalid URL. But at the end of the day, you're rendering it to a byte string. You're rendering it to text. You're sending it out over the network, and you lose all of that beauty. That always happens at the boundaries. You also get it the other way around. Someone makes a request to your application, and boom, it comes in as a stream of bytes, and you've got to parse that and hope that it turns back into something that's nice and Haskell-y. So the overall solution that we've got is wherever the boundaries are for your application, that's where you go ahead and you deal with the ugliness of the outside world. You deal with the fact that all it is bytes, or all it is a file. And you go ahead and you do the conversion at that point, and then by the time it comes in to your actual application code, you're insulated from it. So the overall answer I'd give you about how to deal with the database is you as the application writer shouldn't be thinking about it. There should be a library, there should be a framework, which is insulating you from that fact. And then you get this really well-typed thing called Postgres config or something like that. And there's no way to accidentally send that in to a MySQL server or to send it into a C or something else. You can only use that to unlock a Postgres database. That's the overall approach that I would say. If I wanted to get crazy and talk about other things, we could start talking about, well, maybe there's something where the deployment system could open up a socket for you beforehand, pass it in as, file descriptor 7 or something along those lines, and you can at least get a little bit more open, more control from the outside world. But for the most part, I would say this really should be staying inside the Haskell world. We should have some Haskell code that's responsible for that buffer with everything else, and make sure that when you're writing your code, you're not thinking about that horrible, ugly mess. Hope that helps.
Over here, some of us would love to use Haskell in our day-to-day jobs. And here in Amsterdam, it's actually not that common to see companies that actually use Haskell in production. I was wondering, from a company like Voltact, are there any tips or comments or stories or any good strategy to actually try to start contaging or infecting our companies with the well-typed and all the type Nazi stuff that we all love?
Right. So I will give you a few tips. The thing that I recommend the most is wait for the right time. I'll give you the counter example. Your company decided that they're going to develop a mobile application. They have to deploy it for Android and for iOS. And you come along and say, we should use Haskell. No, don't do that. That is not Haskell's strength. I wouldn't bother using Haskell for that kind of a use case. You can make it work, but it's not the sweet spot. You should be looking at the sweet spot for Haskell applications. So this is concurrent web services, concurrent network services overall. That's why that's the thing I talked about today. That's where Haskell really shines. I would wait until you've got some kind of a case where there's something which your existing tool chain is going to be difficult for. Let's say that you're a Python shop and you're going to have some performance demands, you're going to have some concurrency demands. You're not quite sure how you're going to approach it. Maybe you've got some Node.js, you've got a bunch of computation, and you're thinking about offloading that to a separate microservice or something along those lines. That's where I would say this is the use case where you should be throwing in Haskell. This is where it's able to shine. Look at a pilot project as a demonstration, and be very upfront. The one thing, some people try to sneak Haskell in the back door, and then boom, there's this big piece of Haskell code that no one knows where it came from. Don't do that. It's not the right way to do it. If you're gonna, if you're writing a few, one-off scripts that really are one-off scripts, not like the 10,000 line Perl script that lives at the company for the next 25 years. If it's really the one-off script, go for it, that's fine, different story. So that's the one way that I recommend getting Haskell in. Wait for the sweet spot and really recommend it and explain, we really think we're gonna get X, Y, and Z benefits out of this. It's gonna be faster, more maintainable, it's gonna be easier on the operations team. Make those cases. And if you're not sure what those cases are, reach out to other people, ask for advice. That's actually one of the things that we do at FP Complete a lot. People will come to us with those kinds of questions. And I will be upfront with people when I think that it's not a use case that Haskell makes sense for, but usually by the time people are asking us about it, it is, and we can give some advice on that. The other completely different time when I say it's worth bringing Haskell in is actually as a training exercise. Functional programming 10 years ago was a scary word. These days, like I was talking to some JavaScript developers a few months back about Rust, believe it or not. I was talking to them about Rust and we were explaining how Rust works. And they said, oh, that's kind of like monads. And I thought that was the funniest conversation I've ever had. So yeah, functional programming is cool. It's in vogue. There are a lot, you can do functional programming or at least some kind of functional style in a lot of languages. But as a training exercise, I would definitely recommend Haskell as the right language to learn functional programming. When you do functional JavaScript or Scala or something like that, anything that has some other paradigm available to you, people are going to fall back to that paradigm. If you force people to do Haskell for a few weeks, learn Haskell, do some kind of exercises in it, they're really going to up their skills. And I think that's something that companies should be open to. If they want their team to be getting new skills, this is a really valuable skill. Even if they never use Haskell again, that right off the bat is a very valuable skill to be able to get a hold of.
Yeah. Thank you.
Yeah.
There's another one here.
Sorry, it's again me. Mentioned that Haskell is a good choice in certain use cases for performance. Yeah, I wouldn't know off the top of my head where to find like figures to bring this evidence on how it performs in a network environment or how it is efficient in terms of GPU usage, etc. Where can I find this data? I can of course set up a Kubernetes cluster and write a prototype application and run my own load tests and create my own data set. That's a bit wrong to do. Is there any like watering hole where this information is available online and I can just shove it in front of the manager and say, yeah, this is data?
Right. So the two resources that I see people referencing a lot are the benchmark game. What do they call it? You guys know what I'm talking about? The benchmark game cross-language comparison?
No.
Shoot. I'll have to look it up. There is a benchmark shootout. That's what it's called. The language shootout. Anyway, they've got a bunch of different languages that they compare. I don't know how up to date it is these days, but 7-8 years ago, there's a lot of competition between implementers for different languages to make their implementations as efficient as possible, which of course led to a whole bunch of obfuscated code making its way in, people thinking that whatever languages were most optimized, well, no one could ever write code like that. So you had these C++, C++ is fast, but then you had these implementations within C++ that no human being would ever want to maintain in their life. Similar with Haskell, to be honest. So that used to show that Haskell was about half the speed of super high-tuned C++. Now, half the speed may not sound great, but basically that was far ahead of the pack on any other kind of comparable language that had similar levels of productivity. So in order to get that level of performance out of C++, you'd have to spend, I'm making up numbers here that are probably not true, 5 to 10 times as much time as you would have to spend to get the performance you got out of Haskell. So that was, I think that was a pretty compelling case for the trade. There is a trade-off, and if you need the top performance, or if you have some kind of hard real-time guarantees that you need to hit, then you're going to need to go to a language that doesn't have a garbage collector. But most things that people have these days, there's a little bit more flexibility than that. The other thing that people reference is the Tech and Power web benchmarks. I have to warn you about those. I don't think Haskell looks particularly good there. I don't think anyone's maintaining the Haskell code these days. I dealt with that quite a bit a few years ago. I stopped maintaining it when I had to spend 2 weeks trying to get them to update to a new version of the compiler. So I don't think that those things are really properly maintained anymore. Haskell probably doesn't look very competitive. We ran some benchmarks recently for, we're actually testing out Rust benchmarks and comparing it against Haskell, but we haven't published those. And I don't know if other people are regularly publishing Haskell benchmarks at this point. The final thing that I'll just mention in all of this is just remember that every single benchmark ever published is a lie. So, you know, don't put too much weight on it. It's a good way for people to feel good about themselves at the end of the day. But if you've got some kind of a use case, probably the best thing to see whether Haskell is going to help is do a minimal version of it and compare it against a minimal version in a different language and see how that goes. And then you can also just use proof by authority and say that Michael Snoyman told you Haskell's super fast. I'll deny I said it though, even though I'm being recorded right now.
Yeah, how would you compare the logging library Rio versus like Redis or Monet?
Sorry, I'm not able to hear the question.
Well, you said logging library Rio, right? The logging library Rio?
Oh, Rio, yes.
Yeah, how would you compare that to like Monad Logger or Katib?
Okay, so Monad Logger and Rio are very similar in the approach. So Rio is a more general purpose library. It's we call it a standard library for Haskell. So it includes a lot of different bells and whistles. And for myself, it supersedes Monad Logger. So I wrote Monad Logger as well. It's a very nuanced difference between the two libraries. It has to do with whether the type class lives on the environment versus on the monad. It's not really too terribly interesting, but Rio does have a more efficient implementation under the surface. And since I'm overall moving everything over to Rio for logging, I would move to Rio as well. I don't have a lot of experience with Katib. Someone asked me about it very recently, and I had to give a very similar answer. I don't have any reason to distrust Katib, and it's doing structured logging. So if you need structured logging, that's definitely something I would look at. If you don't need structured logging, then I wouldn't bother with Katib. I would just continue with Rio. I would definitely, it's one of the things, one of many things on my list I wish I could spend some time looking into it. I haven't had that chance yet, but I haven't heard a horror story about it yet, which is better than a lot of other libraries.
Any other question? You mentioned that you use Docker for Haskell deployments. Is there any way to enforce, to make Haskell runtime respect C-group limits for memory? C-group limits.
I missed some of those words. Could someone repeat it? Sorry.
Yeah. So you mentioned that you use Docker for production deployment, right?
Yes.
And there is such thing as C-group memory limits.
C-group memory units?
Memory limits.
Limits.
Yeah. Is there any way to make Haskell runtime respect these groups limits?
You're saying is there something I could do in my Haskell code to limit the amount of memory it's using based on a C group?
Not in code, but in runtime options, maybe.
Oh. I mean, you can definitely do that at the Docker level. You can definitely give it limits. You can do it Docker or Kubernetes deployments as well. You can say, I don't want to spend, I'm not allowed to allocate more than X amount of memory. And then all hell will break loose when malloc just gives you back something that's going to crash. That's the typical OOM approach on Linux. But yeah, you can definitely use Docker to limit memory usage.
Yeah, but how would you communicate this information to Haskell runtime so it won't overcommit memory?
You can't. That is, as far as I know, there's no specific way to tell the Haskell runtime not to overcommit memory. This is a general problem with the OOM approach that we've got on Linux. The fact that it will overcommit on a regular basis. I'm not sure if there is I'm trying to think. There may be an API call that encourages the runtime to do garbage collection when it hits a certain size, but I'm not certain that that exists.
Thank you.
Sure.
Any other questions? So yeah, there are no more questions. Thank you very much, Michael.
Sure. Thanks, everyone. This was a lot of fun doing. This is actually the first time I've done a remote meetup talk, so thank you very much. It was fun. I didn't have to get out of my pajamas.
Yeah, so thank you very much. Enjoy the rest of your morning or day or night.
I will. Everyone's going to enjoy the rest of the night as well.
Oh, okay. Yeah. So yeah, thank you very much. And
Okay.
yeah, keep in touch. Yeah. Bye.
Bye.
Okay.